Hi students, in this class we will learn about step up and step down transformers. Transformers are classified into two types based on the conversion of voltage level. They are step up and step down transformers. What do you mean by step up transformer? From the name itself it is clear that the voltage is stepped up. That means the low voltage on the primary side is stepped up to high voltage on the secondary side in the case of a step up transformer. For a step up transformer, the number of turns on the secondary side is more when compared with the number of turns on the primary side. We know N represents the number of turns and E represents the voltage. Ns represents the number of turns on the secondary side. Np represents the number of turns on the primary side. Similarly, Es represents the the voltage on the secondary side, and Ep represents the voltage on the primary side. For a step-up transformer, the voltage on the secondary side will be more when compared with the voltage on the primary, because low voltage on the primary is being converted to high voltage. Therefore, Es will be greater than Ep. The number of turns on the secondary will be more than the number of turns on the primary in the case of a step-up transformer. We have already learned about turns ratio. Turns ratio is Ns divided by Np, where Ns is the number of turns on the secondary and Np represents the number of turns on the primary. In the case of a step-up transformer, Ns, the number of turns on the secondary, is always more than the number of turns on the primary. Therefore, this turns ratio, this Ns by Np is the turns ratio, which is represented using the letter small n. This n will be always greater than 1 in the case of step-up transformer. We know P is equal to Vi. The current I is inversely proportional to the voltage when you define power. That is, when V is more, I must be less. And similarly, when V is less, the I must be more. For a step-up transformer, the voltage on the secondary is always more than the voltage on the primary. Therefore, current on the secondary will be always less than the current on the primary, which means the current on the primary will be always greater since the voltage on the primary is less. Therefore, Ip is always greater than Is. If current in the primary coil is more than the current in the secondary coil, the wire in the primary coil must be thicker than the secondary coil. Therefore, how do you define a step-up transformer? A step-up transformer is a type of transformer that converts the low voltage and high current from the primary side of the transformer to the high voltage and low current value on the secondary side of the transformer. This is the diagram for a step-up transformer, where less number of turns are shown on the primary and more number of turns are shown on the secondary. Let us now discuss some of the uses of these step-up transformers. These step-up transformers are widely used in the transmission of electricity. They are used for stepping up the generated power to a higher voltage level for the efficient transmission of electricity. They are also used with television, with wireless sets, with X-ray machines, and so on. These step-up transformers in the X-ray machines will provide a high accelerating voltage. A small step-up transformer is used for voltage boosting for small appliances. They are used in electrical devices such as electric motors, in microwave ovens, inverters, and even stabilizers. A step-up transformer has a wide variety of applications in electrical systems and transmission lines. What is a step-down transformer? Step-down transformer will step down the voltage from high voltage to low voltage. Therefore, the number of turns on the secondary will be less when compared with the number of turns on the primary. Turns ratio is ns by np, which is equal to n, the turns ratio. The number of turns on the secondary is always less in the case of step down transformer. Therefore, the n value will be always less than 1. This is for step down transformer. What about voltage? Secondary voltage is always less than the primary voltage. Therefore, the current in the secondary will be more than the current in the primary. If current in the secondary coil is more than the current in the primary coil, the secondary coil is thicker than in the primary coil. Here for step down transformer, always remember the turns ratio N is less than 1. Can you name the coil of which the wire is thicker in a step up transformer and in a step down transformer? For a step-up transformer, current in the primary coil is more than in the secondary coil. So the wire in the primary coil is thicker than in the secondary coil. What about step-down transformer? For a step-down transformer, current in the secondary coil is more than in the primary. So the wire in the secondary coil is thicker than in the primary coil. Why do you use a thicker coil when the current is more? The use of thicker wire reduces its resistance. For a transformer, there are various losses. Various types of losses are there, such as iron loss, copper loss, hysteresis loss, eddy current loss, etc. Basically, there are two kinds of losses, copper loss and iron loss. This copper loss comes from the resistance of the copper wire which is used for winding. If this resistance is low, then this copper loss can be minimized. We know R is equal to rho L by A. A is the area of cross section. Thicker wire will be having more area of cross section. If A is more, R will be less. Therefore, if you use a thicker wire, the resistance will reduce. And this will reduce the loss of heat energy in that coil. Eddy current loss is another loss, and this can be minimized by using laminated core. This is core loss. That is, it is due to the iron core. Please remember that the copper loss can be minimized by using a thicker wire, and the eddy current loss can be minimized using a laminated core. How do you define a step-down transformer? A step-down transformer is a type of transformer that converts the high voltage and low current. If the voltage is high, the current must be low. From the primary side of the transformer to the low voltage and high current value on the secondary side of the transformer. From the high voltage to low voltage. This is the case of a step-down transformer. The diagram to represent a step-down transformer is shown here. You have to show more number of turns on the primary side and less number of turns on the secondary side. Step-down transformers will step down the voltage. Some of the uses of step-down transformers are: it is used with electric bells,
night electric bulbs, mobile phones, computers, etc. Also, it is used at the power stations before its distribution to the consumers. Transformers are used in power generating station and in power substation. In this diagram, you can see a step-up transformer in the power generating station. The step-up transformer will step up the voltage for transmission purposes. Once it reaches the substation, step-down transformer is used to step down the voltage before reaching the consumers.
Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.